Hi, I'm Alan Ross. I am the managing editor of APC Media, and we are presenting a power panel. My guests today are from a diverse group of companies. We have got John Ulcar, who's the director and co-founder of Crosslink Technology. John will be sharing a little bit about himself. Jeff Dorr, who's the VP of R&D for the HJ family of companies. I love that name, John. It's Jeff. It's HJ family of companies. HJ family of companies. And then Marco Tozzi, who's an old friend and has done this with us a number of times. He's the senior technical advisor for Camlin Energy. Gentlemen, if you wouldn't mind, you're going to do a little bit about a quick intro about you and your company. John, go ahead and start for us.
Hi, I'm John Ulcar, and I'm the founder and owner of Crosslink Technology. We actually are a company that does formulating for the electronic industry. We supply products actually for the casting of dry type transformers, PTs, CTs, and various coils and windings. We do work primarily in the epoxy and urethane industry. And for today's discussion, we actually produce and actually make bushings for various electrical parts in the transformer industry as well, particularly for the transformer industry. I'm going to talk a little bit, I guess, about some of the current issues. I think is exciting. It's a problem. It's also a good problem to have. It's the availability of supply in the transformer market. The U.S. Department of Energy is predicting a growth of over 260% in demand for new transformers over the next couple of years. They're creating more. Yes, Alan?
John, let me let Jeff and Marco introduce themselves, then we'll get into the discussion.
Oh, okay, sure, okay.
Sorry, I know you've got the answer, so we're going to get there. Jeff, same thing, a little bit about your background in the company.
Jeff Dorr, VP of R&D, the HJ family of companies, degrees in mechanical engineering and engineering management. I also participate in the IEEE transformer switchgear and insulated conductors committees, and been with the company for 22 years. Started off as actually an engineering intern and had various roles in design engineering, design of components, machinery, and testing throughout my career. The company, HJ Family of Companies, is located in High Ridge, Missouri. So we're just southwest of St. Louis. We have been in business for 55 years and primarily in the transformer and switchgear components and services. We have 4 manufacturing facilities ourselves, and then we have a dozen sales offices in a dozen countries, 18 sales offices total, and then numerous partner locations in 11 different countries.
And that's why you call it the family of companies. I like that.
We are.
All right. Marco, a little bit about yourself.
Yeah, thank you, Alan. So my background is electrical engineering, and my PhD was on partial discharges at the University of Bologna. I've been working for Camlin for 12 years now, and recently we created this new department, Asset Performances, and I'm the director of this new department, so it's pretty new, let's say, in the company. Camlin is 600 people company. We started 50 of us 12 years ago, so a fast growth. And even if we are not a new company, back in 2000, we created the first photoacoustic-based system for DGA monitors, okay, at that time. As a company, we provide the sensors, softwares, and services to optimize the asset performances of the customers. The headquarters is Northern Ireland, but then we have offices everywhere. I'm happy to work here in the sunshine of Italy. So we are quite everywhere, and we have an office in Atlanta now, so spreading a little bit.
Yeah, I'm waiting on the invite to the office in Atlanta. Let's go
Me
ahead and
too.
get
Me too.
started. They gave it to me, but I didn't get it from the people here. But anyway, we'll get started. Um, let's now talk about. We're gonna have a flow of discussion, and we have a little thing amongst ourselves. That means you can follow up on what somebody's saying. John, you started it. Because the first thing is before we get into bushings or monitoring or a lot of the changes that are taking place within that part of the industry, you all are in the industry. You are part of the challenges and the changes that are going on. What do you see? Because right now we have a demand for transformers that is far exceeding our supply. Everybody's trying to meet that demand. Utilities, industrials, data centers, adding a lot to it. But just from your perspective, John, as the founder, and you're the president or CEO, which one of those titles can I give you?
Actually, I'm neither. I'm actually now a director
Okay,
and
director.
owner of the company.
A
And
director
we've
and
been
owner.
in
Well,
business
see,
for over 43 years.
then I'm going to give you a title of king. You are the king.
Okay.
No, John, talk a little bit because I know you are a student of the industry as well. Talk a little bit about your perspective of where we are.
Okay, so like I was saying, and you mentioned it as well, the Department of Energy is predicting 260% growth in the next couple of years just in the demand. But on top of that, with the more building of high voltage transmission wires, there's going to be requirement for more transformers, obviously, and more bushings. It's also estimated right now that about 35% of the current transformers are near the end of their useful life and they're going to have to be replaced. So these are all almost additive stresses on the demand. And actually, also, there's another thing that I'm not sure if it's totally obvious to a number of people is that because of environmental factors, and weather events, such as more hurricanes, stronger storms, a number of utilities are going away from pole top transformers to pad mount transformers, which again is just another stressor in terms of demand. And again, and one thing that kind of doesn't, well, it does relate, but which is I think could be a bottleneck is could be affecting us as well as I guess being an aggregate supplier is that the supply of steel for transformer cores is a real issue, and that could be affecting again. If you can't get the transformer cores, it's very difficult to make transformers, obviously, which affects the whole supply chain. So
We'll
that's
talk
kind of
about Yeah, we'll talk about that in a minute. TMAA is an alliance partner of ours, and they are working mightily on that issue of steel for core transformers. Jeff, your thoughts on the industry?
As John said, unprecedented demand right now. We're busy as ever. Um, Challenges, in supply chain haven't impacted us too much, but it's something that we're closely watching. We maintain very good levels, months of a lot of the inventory. We do a lot of porcelain assemblies, and anytime you're importing components like that, you got to make sure you have a good, steady supply. On the epoxy bushing side, we've developed a line of epoxy bushings for pole mount transformers that are slimmer, robust. They very customizable. They have the typical eye bolt and two-hole spade terminations, but very customizable. With new tooling and everything. So that's the way we're kind of responding to that challenge, is in terms of reliability, but also to help us supply something we can do entirely here.
Marco, what's going on in you? Actually, Marco, you're global because we brought you all the way to Austin, Texas years ago, and you spoke at and presented at one of our expos. Correct? That's where I met you, as a matter of fact.
Yeah, yeah. So I'm a bit on the other side. I mean, Jeff and John, you guys are on the supply of components and bushings. I see the other side of the coin, what happens in the field, because we help to assess the condition of the bushings, the condition of the transformer, and so on. And as you say, in particular, Jeff, it's challenging, because there is this crazy balance between, you have to be cheap and reliable and flexible. No? So you can't get everything. And we see situations that are new at this point. For example, transformers with bushings in very bad conditions. You can't do anything, because if you don't have the spare bushing, because the bushing is too old, and to replace the bushing, you have to replace the GIS. You have to change the layout of the station. So it is better to change the entire transformer. And until you do that, you just pray that the bushing doesn't explode.
Yeah.
So we have a phase shifters here between Italy, France, and so on. You can't touch them, because no new transformer will fit the footprint where the transformer is. So there is a balance between, really, you have to push hard your asset beyond the end of the life. You have to maintain what you have and plan in advance what you don't have, because you need 5 years to get a new transformer,
Right.
like in US. And bushings play a critical role, because sometimes I see this also in Europe. The transformer is ready to go, but the bushings are not coming in the factory because they come from another supply chain. So a small component will get everything stuck. So it's a quite challenging, I know it sounds maybe obvious, it's quite a challenging period, yes.
Yeah, isn't it funny? We state the obvious, but we still been stating the obvious for several years now, and it's going to be that way. I want to switch, Jeff. I want to ask you a question. We're going to, so we see all of this change. You kind of mentioned this as change within your company, but one of the things we're seeing throughout the industry is a lot of technical advantage. People are using this time to make technical advances and or innovation within their scope, within your specific scope. What's happening within the Bushings supply chain that relates to innovation and technical advances?
There's a few things. One is with some of the connector bushings. IEEE standards, they top out at 35 kV, an IEEE 386 standard for separable connector plug-in bushings, whereas in Europe they have the higher voltages there, so kind of adapting those. There's been a discussion in the IEEE Insulated Conductors Committee on how to push that higher. Of course, the market demands some of these components quicker than the standards will respond to them. So we're keeping up on that and have developed plug-in bushings of our own for 52 kV and 72.5 kV classes. But also with the increased transformer capacities, particularly in renewables, they're running these things up to ratings and even over sometimes. So things are running hotter, and the components need to meet those demands. We see a lot of on and off, particularly with solar, go from 0% to 100% when the sun comes up. And not only do the bushing and other component materials need to, the bulk insulation need to be able to handle that kind of stuff. The gaskets as well, are always a thing you have to consider. And not just from the temperatures we're seeing, but compatibility with all the different fluids that are being used now. And with those fluids, maybe they've been proven for a while, as you elevate the temperatures, present new challenges as well. So making sure you maintain that compatibility throughout the temperature range. And that's something we've been working on as well with some of the fluid manufacturers.
We're going to talk about that when we talk about collaboration. John, innovation and technology, what's happening out there? I know Crosslink, you guys, I know a little bit about what you do, and you're kind of at the forefront of a lot of the technology changes and advances yourself as a company.
Okay, so actually, we're looking at it again more internally in this case. So yeah, actually, we're looking at it from like 3 points of view at this point. One is, as everybody knows, like porcelain bushings, just by their nature are very good at self-cleaning. They have great longevity in various environments. And we actually are working on developing new epoxy formulations that actually have better improvements in terms of surface energy and water resistance. And to give longer life in terms of the not contaminating the surfaces, which would cause flashover and those issues. So we're working on those, and we actually are making some progress in small increments, but I think there are still a lot of improvements that we can make over the near future. The other thing that we're working on, which I think is kind of exciting, which is, and I think Marco might appreciate this, is we're actually coming up with insulating materials that would be self-healing during a partial discharge event. So that would obviously prevent the deterioration of the insulating material. So I can't go into the detail as to how we're going to do that, but we actually have some research that we're doing. So again, if we can eliminate partial discharge at the initial event, it'll prevent deterioration. And that's something that we're looking at and putting a lot of energy into at this point. And lastly, which is something everybody's thinking about nowadays, is developing more eco-friendly epoxies that are not based on oil supplies, but on plant-based ingredients. That's a little bit more of a challenge because we're not getting the properties of those just yet, but with time, I'm sure those will develop as well.
You covered a lot. We're going to come back to that because part of what you've just mentioned is the whole demand for sustainability. So many utility customers, the utilities themselves, are putting sustainability as one of their corporate goals. And then that puts that requirement on their suppliers of transformers and other things, which puts that requirement on you because it's kind of a pass up, pass down. Everything you do for sustainability gives them credit, vice versa. So Marco, I want to go back to that same thing, technology and change. And you can start with the self-healing partial discharge.
Yeah.
Like,
I'll go there. I'll go there. Yes. So on the high voltage side, bushings are graded. Okay, so condenser type graded with aluminum conductors and so on. Okay, at the moment there are 3 technologies available produced. One is the oil impregnation, oil impregnated paper. The other one is the resin impregnated paper, and the new one is the synthetic resin bushings. Okay, RIS. Okay, 80% of bushings today in the field are oil impregnated.
right.
RIP is coming up. RIS not yet in the mainstream, let's say, but they are coming. Every of these different technology is trying to solve some problem. For example, the resin changed the game in terms also about being eco-friendly, reduce the risk of explosions, for example. The synthetic ones, for example, they replace the paper in order to have less aging due to the moisture entering in the paper and so on. For the resin impregnated paper, RIP, one of the problems is partial discharges, for example, because that material will not withstand a partial discharge. And we have seen this monitoring these bushings that sometimes you see the PD due to a cavity, and the cavity then evolves in a short circuit between the layers. So the future is looking at the synthetic materials, synthetic fibers, like in the transformers, the synthetic oils, then ester oils, and so on. So this is where everyone is looking at. At the moment, we are still dealing, of course, with the oil, impregnated paper, and ceramic sheds, and so on, which are very, of course, risky for the health and safety.
Yeah. John, are you all working on any of the synthetics that I thought you were.
We are, but those are all work in progress right now, and I'm not really ready to get into that just yet.
Okay.
I'm not trying to be loose. It's just too early to discuss those.
Okay.
With meaning for it to be meaningful at this point.
But talk about this. Okay, if you think about the transformation, before we go on to the next line of thought, you've got this existing infrastructure. Is it possible that there's a great demand if your demand is limited by the supply of transformers coming out of transformer manufacturers? Is there another market to be able to meet the demand of bushings within existing transformers, kind of like what Marco talked about?
Mhm.
Is that a viable market or not? Because I think you do some customization, right, John?
We do actually quite a lot of customization, and we Actually, it's almost like a trifecta because we are now customizing in collaboration with hydro companies and the transformer manufacturers. So there's, I guess, three sets of engineers that are developing products. So we are actually involved in the final design, which includes number of sheds, creep distance, and all those things. So our engineers are collaborating with our supplier engineers and the end user engineers at this point, and we're developing customized products. And we do, and obviously they do all the testing to ensure that they meet all the requirements. But
I
that's
love it.
exciting to have that type of collaboration.
I love it when somebody goes to the next question and does it for me. So, John, talk about collab. No, it's the idea that today, because if you remember in the day, the whole thing was here's the spec, give me your quote on the spec. You weren't even allowed to talk to the customer's engineers. Seriously, back when I started in engineering, we used to talk with customers. It would be either way. Hey, can we do something better? We haven't even sent out for bid yet, but can you help us? Are we bidding the right thing? And you could have a conversation. Not now today, because the procurement people say, oh, no, 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 you can't talk to them. And so consequently, there's been this pendulum that swung over here, and I call it the purchasing pendulum. It's all about the bid, the purchase. You can't talk to them. It's switching back where now people are going collaborate with customers, sole source. Hey, if you can come in and help us develop a better way of doing things, which ties to what we just talked about, innovation and technology. Speak a little bit more, John, about what you've just said about collaborating with customers, where your engineers are working with engineers, not just at the OEMs. You're also they're working with, and you're working with the utility company, correct?
That's correct. Yeah, they're trying to innovate with, they're involved in dealing with tighter spaces. Dimensions are becoming much more important. Temperature rise, and even actually the way we're connecting the components together, are all becoming much more unique. And actually, to your point, Alan, I remember again years ago, we were given a drawing by our customer and said, "Can you make this? Yes or no?" And there was no room for development. It was, can you make it? Yes. And what's your price?
Yes.
Whereas now, they're actually talking to us about saying, developing, products that can be, maybe uh, able to handle a higher electrical stress, a higher mechanical stress under certain conditions, and can we, make parts designed in such a way to meet those requirements and to fit within the spaces that they're, limited by at this point.
Yeah. Yeah. So that is a good switch. I love, because I think it shouldn't be all engineering and it shouldn't be all procurement. There's that wonderful thing in between where we work together. I call it collaboration. Jeff, collaboration with your number one, with your OEMs, your customers, and collaborating with their customers to bring a new product, a new technology, or solve a problem.
We've seen all the way from, as you said, send us a drawing, make it exactly like that. And we can do that, but those aren't the fun ones. We like to work with the customers where sometimes they just bring us an idea. They bring us constraints. We need constraints to be able to have somewhere to start. And we work alongside them, passing ideas back and forth. We have a number of experienced people in our engineering department where we do 3D modeling, we do simulations, electrical, mechanical, we do flow simulations for our epoxy molding and casting as well, and then make tooling in-house, source all the components, and we have a high voltage test laboratory where we're able to do the testing for the customer. We've even had customers come in, witness their testing, and we're working along beside each other to make changes and to develop the product together.
That's it. That's the future. Marco, I know at Camlin, you're working on big projects, little projects, but the same thing happens. It used to be, hey, we want to monitor and bid on it, and you'd have three companies bid. That's not the case anymore because there's
No.
so much more than just the monitor. It's the whole diagnostics and what do you do? Talk a little bit about your experience with collaboration.
Yeah, it has changed a lot, completely in 10 years, I would say. Now, we were used to just, ship the box, take the monitor, fight for tenders, picocoulomb versus volt, gas chromatography versus technology fight. It's not
Right.
that anymore. It's not that anymore because it's now more about can you really support your customer to find what the problem is, to find the solution. Completely different. We are now together, for example, with a monitor, giving multi-year service to analyze the data, to understand the data, because otherwise you just have monitors that don't give any information. So with some customer, it is possible to proactively operate in a way that you find the problem. For example, we published a paper years ago with Altalink Canada. We
Yeah.
found the problem on one bushing, and thanks to that problem, finding what the problem was, opening the bushing, they could save a number of transformers and replace the full batch of bushings with a potential problem. So from one bushing, you save maybe 20 transformers. And this was thanks to the asset manager, the subject matter expert of the company that wanted to find the problem. And this is the kind of cooperation. Also in the specification writing, we help to write the specification of the transformer sometimes because the risk management starts from there. Because
Right.
as you say, there is the procurement, there is there are other steps. But if the specification is wrong at the beginning, is already a problem in terms of
Right.
risk management. No, so everything has changed a lot. Yes.
There's a term in the reliability world. Go ahead, John.
Yeah, so I'm gonna just slightly change, and this goes to actually a comment that Marco made before, and even Jeff as well. Like where Jeff was saying, they have components, 6 months supply ahead of time for their customers, and Marco was saying a lot of times, transformers are held up because bushings aren't being delivered. And again, going back, a number of years ago, we were at the mercy of the purchasing agents, and they knew, 6 months, 9 months, a year down the road that these transformers were going to be built, and then they ordered the bushings at the last minute, and obviously it's holding up, a large transformer. So again, part of the collaboration was, I'm not so I wouldn't say that we were educating the purchasing agents, but we were collaborating with them, saying, okay, ahead of time, what you need, give us a little bit more lead time. And conversely, once we were able to determine their demands, we were able obviously to bring supplies in, to meet those demands over, like I said, 6 to 9 months, as Jeff was mentioning as well.
Yeah.
So again, it goes before, like again with the drawings, we were given a drawing, take it or leave it, and it was also here's a purchase order, take it or leave it. And now
Yeah.
again, we're even collaborating even with these purchasing agents now.
All right. So you did a save for purchasing agents, because I threw them under the bus. You brought them out from under that bus. So you got it. We got a question in rosin impregnated bushings instead of PU foam. Can thixotropic fluids serve the same purpose? I'm going to take that one to whoever wants to raise their hand and say they got it. Did you hear what the question was? In RIP bushings, instead of PU foam, can thixotropic fluids serve the same purpose? Because I have no idea what that question means.
Okay, I'm a chemist. Okay, so I'm not familiar with those types of bushings. Uh, I'm very, very familiar with the thixotropic materials. And I'm just trying to understand how it would relate to a PU foam. I understand PU foams as well.
Yeah.
I don't have an answer on that. I apologize.
All right.
Similar. I don't have
So,
a great answer. The
okay.
with the dry foams, it's keeping it a truly dry bushing. And once you introduce that thixotropic material, or if you increase the possibility of explosion in those bushings again, which is what we were trying to eliminate in the first place.
Okay. So now we're going to switch and we're going to go back to that next set of questions. We want to talk about that failure modes. What are the failure modes that we're seeing as it relates to bushings? Now, I used to say the weakest part of a transformer is the gasket where the bushing attaches and it's covered up because it's a thin gasketing material and the sun beats down and the wind goes and it goes from minus X degrees to, and that gasket material, when it then breaks, becomes brittle, and you get moisture that can egress into the transformer. So was I right in saying one of the failure modes is the gasket failure mode?
Absolutely.
Okay, good.
That,
I just wanted
that,
to know that I was right. Now, what are some of the other failure modes? Jeff, we're going to start with you.
well, I guess I don't want to move past the gaskets just yet. That's an
Okay,
important
good.
one. I know it's a common failure mode for bushings. It's something that I think we've handled very well in identifying good quality materials and identifying the right materials for the application. UV is a concern more for certain materials than others, but shielding the gaskets from that UV becomes important. But again, making sure they're suited to the temperature that they're going to be operating at. And with some new materials, we've got one now where we're pushing insulation temperatures up. You got to do the same thing with the gaskets. And there's materials available to increase those temperatures. Some come with a hefty price. Others more reasonable, but you got to select the one that is going to hit those high temperatures, but also not sacrifice on the low side as well. A lot of these transformers are stored in very cold temperatures before they're put in service.
Right.
You can have that affecting the gasket from the get-go and creating a loss of life before the transformer is even put into service.
Right. Right. Marco, you've seen a lot of them. You mentioned the failure, just you see the potential, like that one bushing you're talking about, that you could determine from that what the failure might be for the other bushings. Talk a little bit about from the high voltage side, failure modes.
Yeah, on the high voltage side, well, the failures are, as I would say, as always, they start as a mechanical or thermal or dielectric nature. When they fail dielectrically. I mean, the dielectric fail. Apart from situations like you might have, for example, a bad connection on the top of the bushing, low oil or gaskets, the internal failures typically are two. One is the dielectric failure due to the short circuit between internal layers, to keep it simple. The other is contamination of the insulation. The contamination can be, like in that case we found, was particles coming from external environment during the manufacturing process, metallic particles, or can be contamination due to moisture, which maybe is the most common failure mode for oil impregnated paper bushing. So moisture that enters from the gaskets, very, very likely, okay? Moisture enters, gets trapped in the paper, and then they immigrates between paper and oil, which means, and maybe this will open another question later, which means that sometimes you do the test and the bushing is cold and everything is fine. Then the bushing heats up during the summer season or because there is high load, the moisture gets out of the paper, the tan delta is the power factor changes, and you find the problem. So it is not immediate to find those problems. But I would say mainly we're talking about dielectric failure between the layers and contamination. These are the main two failures.
John, I'm sorry. Go ahead, Jeff. You comment on that?
I was just wondering on the dry type bushings, they commonly don't have any sort of overload capacity. I know it's been a topic of discussion in the IEEE Transformers Committee, how much that's contributed to field failures when currents exceed the continuous operating current of the transformer, or more importantly, for the bushing itself.
John, you mentioned that when you talked about renewables, right? You were talking about, yeah.
But okay, to go to again some of the other comments from Jeff and Marco, cracking actually, and again this goes to thermal cycling. If you don't have the proper materials, again, and the cycling can happen because of the various environments, whether you're far up north or in the, near the equator. And you could be any transformer during transport and in use. could be cycling from minus 40 degrees Celsius to 120 degrees Celsius a number of times. And if the bushing can't withstand that amount of cycling, and again, it has to do with coefficient of thermal expansion, coefficient of thermal conductivity, then you can have cracking. But we've also found, micro cracks during installation. And in some cases, the installers aren't following proper protocol, putting, in some cases, undue stresses on, and you don't necessarily see those micro cracks until, again, they're installed and go into use, and all of a sudden, you have electrical failures, unfortunately. And with just one other problem we've seen in the field at times is that there could be leakage going between the interface of the conductor and the epoxy itself, where you would have leakage, and there could be ingress of contamination going back into the transformer, so the transformer model becomes compromised.
Okay, gentlemen, we're going to move to, we asked that one question, and we've got a number of questions, and we're going to have to get them answered before we have to get out of here, because I want to give you time to talk a little bit about your companies. This one is more of a statement, I think, than a question, but I would ask you to comment on it. And it came in from the audience. A number of 35 kV bushing failures, and it talked about specifically 15 failures on one wind site, have been reported after VLF, and it's 0.1 hertz cable commissioning tests. Evidence of electrical treeing typical of 0.1 hertz was observed. Some equipment manufacturers are voiding warranties if contractors perform VLF tests on their equipment, and they are recommending tests at power frequency. Do you have any experience with bushing failures after VLF testing? And do you have any recommendation how to avoid these problems? Very specific question. Let's start with you, Jeff. You look like you smiled and you understood it.
Well, a bit of experience with it. I know with I believe they're referring to the separable connector bushings, and those typically would have a DC test in the past and ratings for those on those bushings. I think now the standards have put that in a annex, the test for DC withstand, and I understand that VLF is kind of more favored now to test those cables in the field while installed in the bushings. I can't say I've seen treeing that's occurred, but we actually had some of our bushings tested VLF in the field that were reported failures. We received them back and fully tested them, and they passed everything. So sometimes it's the installation of the connector on that bushing.
Okay.
Silicone grease is applied to the interface surface of the bushing, and if that interface isn't clean, if the grease isn't applied correctly, then the voltage can pass through there. I think with the VLF voltages used that I've seen, that it should work based on the DC and AC withstand capabilities of the bushing. But I don't know, I guess time will tell on that. But as far as voiding warranties, it's interesting.
Yeah, voiding warranties, that's a little scary. John, any thoughts on that?
Okay, so I'm not an electrical engineer, so I can't specifically comment on the electrical part of that. But we have not had any failures in the field that I would be able to comment on at this point. I'm not that comment. We just haven't had failures in the field, so
Okay.
I can't comment on that specifically.
Okay. Marco, you seem to understand that question. Thoughts?
Well, I don't have experience on the bushings with that. I just had experience in the past on cables in my previous job experience doing VLF test. And of course, you have to be careful of which voltage you apply with the VLF and make sure that also the bushings or whatever is attached to the line can withstand the same. Okay, it's not just because it's low frequency, then it doesn't create problems. I mean, the voltage level is also important, but I don't have personal experience on the bushing test VLF.
Yeah. Okay. Another question that we've got, we'll move. This goes back to the collaboration part that we talked about, and this is for all three of you, but particularly John and Jeff, for you as a supplier to the transformer market. What would you tell a young transformer design engineer, and I know several of them, I mean, they're all looking for collaboration, right? What are some of the most critical things for them to consider when specifying bushings for transformers? Let's start with you on that one, Jeff.
Well, I think we've touched on some of these points already, but the loading of the bushing and possible overloading. So what kind of margins are being allowed, depending on the type of bushing construction.
Okay.
With many of the resin types, they're not built for overloading. Some are. So you have to kind of dig into it, see what kind of what materials using, what its capabilities are, and talk to the manufacturers. Same thing goes for gaskets though, right? Even if the insulation itself can handle the overload conditions, even common industry standards allow for thermal short time currents that can be 25 times operating current for a short duration, but it can also allow the bushing to reach temperatures where some damage, some loss of life of that gasket can occur. So gasket selection, whether it be for high temperature, low temperature, chemical compatibility, even UV, as you mentioned earlier, and ozone are all very critical.
Okay. John, any thoughts?
Yeah. So I'm going to say there's a little bit of a difference between, I guess, electrical theory and practice, and so for a young engineer, I would really strongly recommend that they, talk to people that have been in the field for a number of years, because again, there's the theoretical amount of amperes that you can put through copper, like per square inch, and obviously in most transformer users, I'm not saying the manufacturers, but people that are using them beyond their normal specifications. So they're overloading them. They're being used past their limits, and in most cases, they're doing quite well. So they're obviously over-engineered for their use. But again, if anything, I would tell a young engineer to really pay attention to people that have been around and listen to the practical part of it as well.
Okay. All right. Marco, it's a different thing, but it's the same thing. What would you tell somebody who's designing a monitoring program for transformers, and they're asking you, what should I be looking for and at?
Hey, you have to do the right, ask the right questions at the beginning before starting to do the design. And what Jeff was saying about the overloading, for example, is very important. And practical case, we do overloading calculations for transformers. We see people doing that. And sometimes you might not consider, for example, bushings and tap changer in your calculations because you are doing the calculations of the transformer. So you look around the windings, the maximum current in the windings and so on. And you might forget that, by the way, if you apply that current, you are exceeding the current of the bushings. So bushings are important accessories of the transformer, very critical. So also in the specification and design stage, you have to consider also the abnormal behavior around the transformer, let's say in overloading and over voltages. A recent theme is the fast switching transients from GIS. Okay, it's something that is apparently causing some issue to some design of bushings, especially with resin. So it is not like before just design the bushing basing on voltage and current. You have to consider also the environment where the transformer is supposed to operate, from electrical phenomenon to the pollution, corrosion category, and so on.
Okay. Um, we're about to move to a point where I really would like to understand better what it is that that your companies are specific. I want to call this the commercial portion of this, but it's really to help other people understand what it is that you specifically do for those that have said, "Hey, I'd like to find out more." We did have one more good question I've got to ask about, and it says. It's difficult for the collaboration because supply chain is about project departments. Meanwhile, innovative solutions needed to come from operations units. This is not a question, it's a statement. It may be a better solution to come through universities as intermediate entity, for example. I question that. I think we struggle with academics at the application end of it or at the practical end of it. But thank you for the non-question there. And then one more last question. As renewable energy demand has increased, has it introduced new challenges and potential concerns for failure? And I think, John, you started on that one. Why don't you take that question to start with?
Okay, yeah. So because we're not able to meet the demand just yet. There is going to be more stress on the current infrastructure, and just by nature of overuse or stress, there is potential for transformer failures, more transformer failures because they are being run past their specifications.
All right, Jeff?
I think along with that, we're finding a need to make equipment more robust to handle those applications where they're run harder, renewables, but even just in utility applications, there's somewhat of a push to increase loading on the transformers. So responding to that. We talked about monitoring earlier, and that's something we've gotten into as well, is monitoring of even smaller distribution transformers. It has some uses in critical installations, remote areas where you can monitor a transformer's health, looking at voltage and current, pressures, temperatures, and recognize when it's approaching failure. And that way you can quickly respond with a replacement of transformer, but also you've got the data to decide if you need to upsize that transformer before you even get there.
I'm going to pick up on a question. I was at a conference and one of the speakers, one of the panelists was from Southern Cal Edison, and he mentioned the fact that because of all the transients, increased transients from renewables, particularly from solar and wind, that it is exacerbating the failure rate of transformers. They're aging faster as a result of all of these renewables coming in because they were never designed to be step up, step everywhere, right? They were pretty much designed to be step down transformers. And so the idea that a lot of the renewables that come into the market create a system that ages. Have you found that to be the case? Because is it aging bushings more rapidly? Jeff, start with you.
It can be certainly. I know reverse flow in transformers is a concern, but one thing is with the harmonics from the inverters has been an issue because now it's being addressed. They're shielding the cores of the transformer to prevent the harmonics from, through capacitive coupling, transferring through the core to the medium voltage side, where it was causing problems for bushings and connectors and cables and the transformers themselves, right?
Yeah. John, you heard anything on that? I call it super aging of an existing infrastructure.
Yeah, it's basically like I mentioned before. We're just basically running the equipment hotter than it was intended for, and it is aging faster. I'm not sure. No, we are actually developing, and actually our customers, the OEMs, are developing transformers that are more robust, able to handle higher stresses. But again, that's still just meeting the current demand. We still haven't been able to catch up to the demand that is coming.
Mm-hmm. Okay. Marco, any thoughts on that?
Well, I agree with what has been said. So definitely there is an impact, and there are utilities that are taking countermeasures, for example, installing true fault current monitors or anyway devices that can understand what happens outside the transformer, because their transformer was supposed to work in a certain way, and then they maybe are facing 20 short circuits in the distribution grid or coming from other plants that were not supposed to withstand, affecting the mechanical structure. So things are also changing to face this input from the renewables. But also in the renewables itself, in the plant, they have quite a good challenge because they don't have the technical knowledge of the historical electrical utilities, and their transformer are operating in an unknown environment,
Yeah.
and with not the same support the utilities typically have, because everything is seen purely from the financial point of view. Now the transformer is just a node of
Yeah.
sort of the cash flow in a certain extent. So they are facing a lot of challenges already with the existing step up, the main step up, connected to the grid.
Right.
So yeah.
Okay. We're gonna switch gears. Our two sponsors for this were the HJ family of companies and uh, Crosslink Technologies. Jeff, talk a little bit about the company specifically. What's going on at HJ? And if you were talking to me as a prospective client, why should I do business with you?
All right. Well, I'm not in sales, but I'll give it a shot.
I don't want to talk
Um,
to sales. I don't want to talk to a salesperson. I want to talk to the engineering team.
sure, sure. So we're busy. Lots going on. A lot of growth. And in terms of our manufacturing, our epoxy molding operation, tremendous growth. We have a number of materials, not as many as Crosslink, I can tell you that, but the materials we have developed here, our chemical engineering director uh, formulates the resins in-house, and we run them through rigorous testing. We're optimizing our formulas for use in our process, on our components, with our equipment. So that's worked very well for us. We've recently, for our APG process, added a larger press than we've ever had before. The platen size is 3 times, so we're able to mold components right now, our largest ever, several 100 pounds, multiple copper conductors encapsulated in epoxy. So that's been interesting. Development of other products for for power transformers. We have nitrogen blanketing systems for oil preservation. I mentioned before some new epoxy bushings for pole mount transformers. Doing a lot of work with higher temperature epoxies to for them to work with our bushings, low and medium voltage, to hit the 130C, 155C temperature ranges. And I mentioned before, we have a high voltage laboratory where we're rigorously testing all that. And we mentioned before, we got hundreds of years in design experience combined. We have a lot of people that have worked in the industry for decades that come to work for us full time, or we have some that are now semi-retired and work for us as consultants. But absolutely a great help to us. So let's see what else.
I think you've covered enough. Thank
Yeah,
you, Jeff. When you have to
thanks.
look there and you have to find here, because I need to get to John. John, now Jeff said I'm not sales. He's in, he approaches it from the technology. You're the founder. You are the number one salesperson, even though you come at it from the technical part. Talk about Crosslink Technologies, because I know a lot of what you do, and you are a very unique company.
Okay, so actually, I won't say I'm a salesperson. I've never sold anything. I have great salespeople that work for me. I consider myself a techie. I love the technology part of it. So
Right.
that's what I'm going to talk about. Um, okay, so we consider ourselves to be very, very innovative. Everything we do, we try to actually it's really meant to be customizable to the customer. We do I'm going to say projects that other people don't want to do or think it takes too much time. We actually like to customize to the engineer's needs and things like that. And I'm going to say our philosophy is not so much to make our specific customer company successful, but to actually make the engineers look successful. So he comes up with a design, we make the design, it becomes very successful. He becomes successful within his own company, and he looks good. The company looks good. They have a good product. So that's where we're looking at, and even within that concept of innovation, we're also doing that internally, so that we can turn parts around faster. Again, lead times are always a big issue with customers. We're finding ways of lowering our lead times, keeping quality and delivery, at 100%. But it's really, I'm going to say, very much in our case, very much a partnering thing. We obviously have electrical engineers, we have mechanical engineers on staff that are there to support our customers. So it's very much that we customize the designs and the processes to meet our customers' needs.
Excellent, thank you. And Marco, you get to talk a little bit about Camlin Energy and that part of Camlin Energy is part of a bigger thing, Camlin Group, correct?
Yeah, correct. The Camlin Group has the Camlin Energy division, where we of course work with utilities and operators in the energy sector. But then we have also another branch that is on the rail, so completely different, let's say, subject. Our mission is really to establish a trusted partnership with customers, really. And that's why we moved from selling the sensors like we did, even 20 years ago, into now the software and the services, because we see this need to assist the customer really, and especially for industrial customers, renewable customers. So critically important, but small customers really need this kind of partnership, which is, by the way, a way to learn every day. Is a mutual learning. Okay, so this is the mission of Camlin. We really operate to go into this direction, to create this partnership, and that's why in US now we are expanding with facilities and offices in order to stay closer to also customers in US. In Italy, we are a big operation, so depending, on the market area, we are expanding to stay close to the customer.
That invite still has to come for the Atlanta office. Interesting, all three of you really addressed that issue is customer centric, customer facing. I will say that the last statement before we end, I will say this as a gray beard, gray hair, right? I'm one of those legacy guys, and I'm not saying, John, that you are, but John, you are, and we have a lot of legacy knowledge, much of it which is very good for the marketplace. Some of it we probably even need to let go of. But the next generation is desperately going to be dependent upon exactly what each of you have talked about: collaboration, communication, educating them, because the next generation of engineer doesn't want to make that mistake. John, as you said, you make the engineer look good, right? But the engineer can also look bad by making a mistake. So the idea that all three of your companies are customer centric, which means they're people centric, which means you're engineering centric, which is, to me, the biggest transition that's taking place within the power industry right now is that transition of teaching the next generation of engineers who specify, who manage, who monitor, who make decisions about the grid. It is incumbent upon us to teach them and to collaborate with them, so that they can make all the mistakes that they want to make, and then they can teach the next generation after us. There has never been the kind of change going on in the power industry in the last 50 years as much as there is today globally. That's both bad and good. And I want to thank each of you, because your companies are recognized as being great partners to be able to help the industry proceed, the industry grow through innovation, technological advancement, collaboration, and the way you do business. So, gentlemen, thank you so much. This has been a power panel from APC Media.
Thank you.
Thank you very much.
Thank you.